Welcome. Welcome to the ARC Advisory Group Additive Manufacturing session at our forum. My name is Mary Ann D'Aquila. I'm a Director of Research and I will be hosting this discussion today. We'll start out with a small video from my side, a small presentation from ARC's viewpoints on the additive manufacturing market. And then we have three terrific speakers that will join us. And then we also have three suppliers that will join us at the end of the session for a panel discussion. I encourage all of you to use our Q&A feature to ask questions throughout the session that we will be asking at the panel. Thank you. Welcome to the ARC Additive Manufacturing session. Additive manufacturing to the rescue. Innovative ways to drive performance. Let's start today's discussion with a look at the major trends and market dynamics increasing the adoption of additive manufacturing, which will set the stage for our session today. The intersection of hardware 3D printer innovation, software, services, and material advances in conjunction with the global pandemic is shining a new light on industrialized additive manufacturing. As part of a broader digital transformation strategy, additive manufacturing is part of the solution for disrupted supply chains, operational efficiencies, and new product development. Whether it is a pandemic, climate disruption, political unrest, no doubt 2020 and COVID-19 has brought the disrupted supply chain potential front and center and has continued to highlight the need for a more dynamic supply chain. As a result, manufacturers are forced to explore additive manufacturing as a substantive role as part of the factory digitization. 3D printing has been around for a long time, but now we're able to embark on a trajectory towards newer use cases, end-to-end volume manufacturing with the advances in software, services, materials, and hardware. Let's take a look at the supply chain. As I mentioned, the pandemic has brought risky supply chains front and center. Supply chains are fragile due to the political turmoil, climate events, pandemics, economic uncertainty. Additive manufacturing mitigates supply chain risk with a design anywhere, produce locally strategy. Additive manufacturing can alleviate expensive, complex manufacturing, shorten lead times, and reduce inventory. Producing locally mitigates the high import-export costs and risky sole sourcing from remote locations. Additive manufacturing can rescue the supply chain. Software advances are instrumental in the process. Generative design is an iterative process that generates multiple design outputs, meeting predefined constraints and requirements for fit, form, and function. Engineers are using generative design software, such as those provided by PLM solution providers, to design for AM, exploring hundreds, if not thousands, of solutions to be evaluated within a relatively short time frame. This is enabling manufacturers to produce products that could not have been engineered a few decades ago. An automated workflow software specific for additive manufacturing will become increasingly important as we move to serial production. This will help companies manage increasing volumes and scale, additive manufacturing operations, monitoring production costs, material usage, and order turnaround times. Now let's talk about services and materials. As with other transformative technologies, adopters are balancing short-term investments for capital expenditures versus much-needed innovation in a competitive world. A rise in subscription-based and pay-per-print models is becoming observed as a result of discretionary spending restrictions and budget limits for capital expenditures. Outsourced production services provide a way to leverage some of the benefits of additive manufacturing, particularly for companies that have put their short-term investments on hold. Manufacturing as a service platforms provide on-demand manufacturing services connecting a global network of manufacturing suppliers to end users. These platforms offer not only additive manufacturing services, but also traditional manufacturing services. And the proliferation of new materials is fundamental in the in the expansion of 3D printing in more use cases and industries. While polymers and metals have the largest installed base, the following material advancements are growing: high-performance thermoplastics, composites, ceramics, elastomers, inks. This is resulting in an even more diverse set of products being designed and produced by 3D printing. Now I'd like to talk about the proliferation of use cases beyond prototyping. Use cases are defined by the way that by the value they create, including new products, operational efficiencies, and enhanced customer services. Additive manufacturing use cases beyond prototyping include but are not limited to parts for new products, parts for aftermarket, such as out in the field when parts fail, jigs, fixtures, molds, and tools to be used on the manufacturing line, and also apparel. Additionally, medical devices and models are not new. 3D printed prosthetics, hearing aids, splints are applications that have been around for a while in additive manufacturing. But implants that are appearing inside the body are becoming more prevalent. This is thanks to the materials, science, and our discussion earlier about generative design. And 3D printing is part of digital dentistry, including orthodontics, implants, crowns, dentures, to name a few. I'd like to wrap up with some of the growth contributors and inhibitors, some of which we've already covered. On the contributors side, companies engaged in digital transformation and the smart factory adopt technologies such as 3D printing, leading to reinvention of products from design through manufacturing as part of an end-to-end solution. The rise of new technologies and suppliers have furthered the capabilities of 3D printing, including increased speed and build size. On the inhibitors side, we still have a long way to go, all of us, in educating the marketplace to reverse the obsolete opinions. Not all companies are as forward-looking as the ones that understand that additive manufacturing is more than just prototyping. It can reduce time from idea to production, can result in cost reductions, and can be environmentally friendly. Many decision makers have decades-old mindsets about 3D printing, thinking it is still an expensive, slow tool simply for prototyping. And the standards discussion has been around for a long time. Lack of comprehensive standards bring an additional risk to companies adopting 3D printing manufacturing, especially safety and critical applications, and those that are heavily regulated. True industrialization would benefit from process materials and post-production standards. And this ties in with quality assurance. Even though the quality of 3D printing is steadily improving, there are still advances to be made in part-to-part variation and material chemistry. And finally, we don't just live in uncertain times, but we are living through unprecedented times. And this is why I put global uncertainty under both an inhibitor and a contributor. Some will see that this time, like no other time in history, is a choice to embrace innovation, to remain competitive. And unfortunately, some will be left behind. I thank you all for your time today and for participating in our discussion. Thank you. Well, I'd now like to turn it over to our first speaker, Faisal Iqbal. He's the digital leader at Baker Hughes. Let's have Faisal take it away, please.
Hello, everyone. My name is Faisal Iqbal. I work for Baker Hughes. I'm responsible for digital transformation for Baker Hughes Additive. Today, I will talk briefly on how at Baker Hughes we see the digital playing a pivotal role in industrialization of additive technologies. What are some of the challenges we faced with it? How are we trying to overcome these challenges? And to that end, what product and services we are providing to our customers. Let me first start by telling you about Baker Hughes, who we are. Many of you know Baker Hughes as an oil and gas services company. So that is still our core business, but over the past few years, we have transformed ourselves into an energy technology company. Look, the global energy industry is changing. Over the next 30 years, energy demand will continue to grow by as much as 30%. While oil continues to remain a big piece of energy mix, the demand for renewables and natural gas will continue to increase. We believe due to our unique product mix for oil field, turbomachinery, and measurement systems tied to digital solutions, we can make energy cleaner, safer, and more efficient for the people and the planet. With that purpose in mind, with over 60,000 employees and 120 countries, we're working together to take energy forward. One of the ways to take energy forward is by leveraging Industry 4.0 technologies. We all know 4IR technologies are disrupting both business and operating models across all industries. The challenge before all of us is how do we effectively use and integrate these technologies to transform our business and operating models, not only maximizing value for our customers and shareholders, but also, and very importantly, to a greater good of community and environment and the world. There is no straightforward answer to this challenge. What we do know that answer does not lie in a single company or an individual technology. It really requires an ecosystem of partners, suppliers, and technologies stitched together for a common purpose. And that is exactly what we are trying to do here at Baker Hughes, as it relates to industrialization of 3D printing, and thus in turn reshaping the supply chain. We are building an ecosystem of partners and technologies, and we're calling it Formist AM ecosystem. We have 8 additive technology centers located globally, leading the way in putting the pieces of ecosystem together. So far, collectively, we have been able to qualify more than 500 parts for production use and have printed over 30,000 of them, currently in use across our portfolio of products. And to go from here to a full-scale industrialization, we see a lot of challenges. For example, we need design tools that are far superior and sophisticated than what industry have been using for the past 20, 30 years. The new tools must carry multi-physics-driven generative design capabilities to drive highly innovative and efficient product design, fully taking advantages of the freedom of design that additive offers. These tools should utilize high-performance computing at scale, not at just the cloud, but also at the edge. The speed of and the timeliness of analysis is extremely critical if we need to quickly replace or repair a part in the oil field by scanning, redesigning, printing, and ensuring it meets quality standards. Now that brings us to quality assurance. For additive to become mainstream supply chain option, new tools and techniques must be developed for ensuring product qualification for 3D printed parts. Let me talk about how we are addressing some of these challenges. Now, starting with AM Marketplace, where our goal is to break down the technological and process barriers that separates order management from manufacturing execution. Now, thus reducing the lead time that traditional supply chain overburdened by convoluted processes and multiple tools just cannot seem to get rid of it. The platform provides our customers full transparency as order gets fulfilled through design to production to inspection to delivery. Another key element of our digital ecosystem is AM Design Studio, where intent is to create a unified environment of product and process design, a seamless digital thread from part design, build planning to build process simulation. We're also using state-of-the-art technologies of CT scanning built by one of our product lines, Waygate Technologies, which is tied to machine learning apps to quickly identify quality issues of 3D printed parts. And in cases where our customers need help in finding potential parts for additive, we are providing services to scan through thousands of parts from ERP and other enterprise systems. One of the key elements of Formist ecosystem is building customer trust by providing detailed quality assurance report encompassing all critical quality data from every stage of the additive process. Through the report, customer can validate that from the time order was received to the time it was designed, built, inspected, and delivered, we not only followed all of the customer requirements set forth for the specific order, but also our internal quality assurance process. And also equally important, the prevailing is industry standards, which by the way, we're actively engaged in driving for the industry. In summary, what I could say is we believe that through Formist additive ecosystem, we would be able to effectively reshape the supply chain for the energy industry to help energy forward. Now, that's the goal I mentioned earlier at the start. Thank you for your time. I'll be very happy to take questions in our subsequent panel discussions.
Faisal, thank you so much for that presentation and for sharing the experiences of qualification and printing of parts, and for touching on the use of new tools such as generative design in shaping the future of the supply chain. Very much appreciated. I'd now like to move it to Dan Straka, please, from InterPRO Additive Manufacturing Group.
Hi, my name is Dan Straka. I'm the president of InterPRO. Today I'm happy to talk about how 3D printing is enabling the future to be bespoke. This is an additive manufacturing journey from prototype to production, featuring InterPRO Additive Manufacturing Group and the Stratasys Origin 1 3D printer. Okay, before we jump into it, a little bit about myself and InterPRO. I started at InterPRO 15 years ago, scrubbing parts in the back, and I've since been fortunate enough to work my way up and work on different departments and different teams, interacting with different materials and processes as the company grew and the industry in general. So InterPRO was founded in 1996 with the idea of being an internet prototype. You know, like what a novel idea back then, that you could have the internet but also buy parts off the internet. And so we've changed from we've grown up quite a lot from a very different company. So now we're around 20 people, and we offer FDM, FFF, large format SLA, multi-jet fusion, and the new addition is the Origin P3 printers. When I started back in 2005, we had two resins. We had white and clear, so very different outfit back then. And we also catered to very different clientele. So we were more or less a model shop, and if we did production work, it went into cast urethane. SLS was just starting to come online to be able to do some production stuff, but it wasn't a ton, at least not that we saw. So we moved on to more like aerospace, defense companies, consumer good companies, engineering outfits, and doing a lot of medical device development. So our clients tend to be larger industrial enterprise grade clientele, partly because the problems they have are very big and complex now, and that's kind of what we're focused on. All right, and so our clients, like any clients, have the normal problems of everyday production, how to get parts to market, products to market quicker, faster, cheaper. But now with COVID in 2020, it was just a totally different experience. The timelines were different, the risks, the weights to the risks were different. We had clients that had internal disruptions. We had clients their clients had internal disruptions, you know, concerned about the market, what things were doing. And so all the normal problems existed, plus this factor of COVID and other things. So there was a lot of questions that they came to us, like, how do we get, these parts that we need cheaper or quicker, right? How do we offset the risks by either, getting the price down, avoiding tooling, and luckily with the Origin printer, we were really able to answer a lot of those questions for certain clients, and which is very gratifying because we kind of jumped into the Origin process with the belief that it could be done, but 2020 really kind of proved that, yeah, we were correct in investing our time and money into this platform. So before I kind of go into some examples of how we did that in 2020 and what we're looking at to do in 2021, I kind of just wanted to talk about a little bit where I think additive manufacturing fits in with the product life cycle. And so this is like kind of, let's say, a typical life cycle of a product where you have sales and time, and you have this like development stage, introduction to the market, growth, and then eventually maturity and decline. So traditionally, when I started at InterPRO, we just did development, and fit form models and 3D printing was really relegated to just that. If you wanted production, it was cast urethane, or you had to go to CNC or injection molding. Maybe some SLS in the beginning when that was starting to really shake out. Nowadays, though, we're still involved in the development, but we're also getting more into this intro period, this introduction to the market where, again, I like to talk about risk and how to offset that risk. And so if you don't have to go to tooling, for example, then you can really lower the bar in terms of a capital or financial investment into a new product line. And particularly if you haven't, if you have a hot market, or you're really you've identified a really particular application, 3D printing can really lower that cost and allow that introduction period to, build up some sales before tooling gets cut, and so forth. And then what we are seeing a lot more now too is this kind of maturity decline phase, where, let's say for maturity saturation, they say we need to remarket it, tweak it to sell off existing inventory or put it into a different market. And then 3D printing can kind of jump in there and help facilitate that. Partly because at this maturity and decline, like the CapEx expense is probably not there for the product. You may have existing inventory, or you have the product in the market already. So not as much money is coming in. There's not as much money to do tooling or other things. So in this decline phase, what we're also seeing too is that they may have older generation units out in the field, but they need to retrofit either because certain parts are wearing out, or they've identified an engineering change that they want to make to improve customer satisfaction. And they need to maintain those machines, whether through contract or just good business practices, but they don't have the same amount of capital to fix these problems like you would in the intro or growth stage, because sales have declined. So you need to be creative and come up with ways to address those needs, and 3D printing is a great fit for that. All right, so the next part I want to talk about is the kind of process evolution of manufacturing in a very general way. And I took this from Seco Tools, but I really like it. It's a really great graph, and it shows like the different stages of manufacturing, and like particularly like the high touch craft manufacturing. And one of the things I think about is I had a relative that used to work at Pratt & Whitney, the aircraft manufacturer and engine manufacturer, in the 50s. And he had a Bridgeport in front of him, and he had a manual lathe behind him, and he would make a part complete, but he would make the same part again and again. Nowadays, a lot of modern day machine shops, you may have, 3 to 4 machines to one person, one machine operator. And then on this graph here, we have the mass production of first generation and the mass production second generation, which they're calling the high volume, low mix. And what I consider that to be, in part, is that, you build a tool, you mold 100,000 million parts, and you sell to 100,000 million customers. A very traditional way of product management and sales. But what they also call out here now is this third generation, this mass production, which is low volume, high mix. And that's an interesting concept. And I think the market has become so much more complex, partly because we have more data to get feedback from clients and to see what they actually want. There's no one coffee maker, right, that is the coffee maker. There's coffee makers for people that really like coffee and the artisanal experience. And then there's, a generic percolator, right? There's all these different products that kind of address different consumers. And this low volume, high mix, I think, is really going to start to take off. And I'll show you some examples shortly where manufacturers, producers, OEMs are able to deliver unique products that are even more tailored because of tools like 3D printing, that they have that now that kind of offset the risks. They can address client needs without paying a butcher's bill and tooling costs or whatnot, or incurring a lot of risk. So this is a bell graph, a bell chart of the economics of the manufacturing process. And I think a lot of life's problems can be associated or shown to reveal on like a bell chart. And here is a very typical, like almost every manufacturing process, I think, can be attributed to this general curve, where you have costs versus quantity. And the cost can be like a landed cost, an amortized cost once CapEx expenses or tooling or amortized into a per part price. So here we have the cost of goods manufactured versus quantity, and where if you have really low quantity, really high cost per part, or once you have really high quantity, the per part of cost is offset. And what's exciting with 3D printing is it follows this same trend, whether it's SLA, FDM, what have you. But with new machines and materials for the Origin P3 printer, you really see a kind of a different conversation starting to happen. At least I'm able to have them. So whereas, yeah, we'll be expensive for like one part due to some of the setup time and calculations that we do. But the exciting thing is where a lot of 3D printing parts, I think, would start to get too expensive once you get up to the 50, 100. You know, we're able to sell parts almost at not quite injection mold prices, but getting close when we're getting up to the thousands, which I haven't had the ability to do that in the past without, you know, losing money or like artificially reducing my margins. That the Origin printer naturally can produce parts very fast, whether it's one part or 50 on the build. The build time ends up being the same. So it's a pretty powerful tool from that perspective. And for a couple other reasons in terms of quality and material properties, which I'll get into, it's very helpful. Okay, now that I've talked about the product life cycle and some of the economy of scale we see with 3D printing, I want to talk about the process in the printer specifically and why that adds a lot of value to that conversation. You know, I think additive manufacturing for production parts has been around for years. A lot of people have been talking about it, and I definitely agree it does exist. I think printers and the ecosystem that the Origin represents will allow more products to exist in that conversation. You know, maybe in another year or so, I think we'll be doing products that are only ever 3D printed off this printer, which is very exciting. So from an ecosystem standpoint, the materials really enable us to do quite a lot more than we have traditionally. For example, the Loctite Hinkle materials come in elastomers, silicone elastomers, high impact, high flex parts, different colors, but also we just started running the FST material which is rated by Airbus for like aerospace applications and burn ratings. So that's very exciting. As a service bureau, every new material is basically a new problem that we can solve for someone. How the printer works is, if you look at the printer on the left, there's a white lattice work. So maybe that printer is about 6 to 8 hours into a build. And there's, in the middle of the machine, there's a vat of photosensitive polymer. And then there's a build head, which is above the lattice work that starts submerged in the polymer against a glass pane. On the opposite side of that glass pane is a digital light projector. And once it turns on, any light that it's shooting out will start to cure that photopolymer. And then as it creates a new layer, that build head will move upwards. And since it's not a laser or an extrusion process, and it's just flashing the entire layer, if it's building one part, it's the same build time if there's 100, if you can fit 100 on that build head, or 50 or 10, which I'll show in the application shortly. So that's very exciting. And on an operational point of view, there's a lot of controls within the printer which enable the team to be very successful on a day-to-day. There's thermal cameras, there's like heated glass, there's a heated chamber, there's humidity sensors. There's quite a lot in there that you don't necessarily see in a lot of other printers. It gives the operators a good sense of control of what might be going on and react if something is happening. And the Origin team has been really amazing supporting us in this endeavor over the last year, and in terms of onboarding new programs. But it's all good and exciting. And let me jump into some applications to kind of start to show what we've been up to. All right, the first application I want to talk about is this Distech motor mount adapter. And I like talking about it because it's one of the first ones we did, and I still think it's one of the best in a way, because it encompassed the vision that I had for the Origin system and what it was capable of doing. So the situation was that Distech had a motor mount adapter. So they sell this Bio 1 mixing unit, and it's got a motor that gets mounted to the top and spins everything. And what they were finding was that their clients that they were selling these to often had their own motors, so they didn't want to purchase Distech's motors. So they didn't want this high ticket item, their core product, the sales to be impacted or impeded by this issue with clients wanting to use their own. So they came up with this adapter, which allowed people to use their motor or any other motor. And as you can see, this component, the way it was designed, you wouldn't be able to manufacture that traditionally, not very easily. You wouldn't be able to machine that. You certainly wouldn't injection mold it. And even like a hand process like cast earthing would probably struggle to produce as nice of a part. For this part, the Origin did extremely well on. We built it in the Loctite, the 3843 material, which is a matte black, and you can see from the surfaces, it's a nice, appealing, customer-facing part. It looks production ready. And the way Distech kind of benefited from that, and as well as their clients, is that they were able to print the SKU for their core part as they needed them. So it's almost like that digital warehousing experience. So they wouldn't have a lot of stuff on the shelf, but they could also have a lot of different SKU numbers for all the other motors out there. So as clients would come in and say they had their motors, we would just 3D print them as needed. And so I think it's a great story because it was a business facilitator. It wasn't necessarily about driving price point down, but it decreased risk because they were able to address client concerns very real time and not impede their core product sales. All right, this is a neat application, and there's a little video playing, and you can see an operator squeezing this part, which you can't do on too many 3D printed components and have that spring. This is actually a neat material. It's the 3172 clear by Loctite, and it's got an elongation of 141%. So on this particular part, this is an application job, but I wanted to share it where we can show how like an advanced prototype from an engineered material really help advance the conversation of what to do with a particular situation. So the challenge was they needed to test out and fit this material before it goes into a second run of production. And what you can see there on the left is the molded part, and on the right is the Origin part. And to be honest, I couldn't tell the difference when the client sent me these pictures, and because it was so close. But it's kind of a neat thing, and it's one of the reasons why I got into the Origin to begin with, is because I was so impressed with their material ecosystem that they could accommodate between Loctite, BASF, and DSM, all these different materials. And from a service provider standpoint, that just meant those are that many more problems we can solve. So a very cool application. All right, here's another application which I like a lot. And I like it because I think it's very simple. It's not a turbine, it's not a turbine on a plane, but it's still a very excellent part to be additive manufactured. And I think it's a very good everyday part. And so what this is just basically a detent. It's a detent that gets depressed, and then it activates a sear that launches, allows something to pass through. So very, very simple, but the part itself has some unique angles, which makes CNC not ideal. You can definitely CNC it. There's some compromises with radii that you'd have to make, but also for the count that they were looking for, maybe 200, 300 of everything really worked out well. It's fairly expensive. And to machine that part out of like an HDPE or a PolyPro is, again, not ideal. And so you could injection mold it if you cored some parts out. But again, a tool cost, let's say it's $5 grand, maybe $8 grand for a tool, is just way too expensive for the part price they needed. So printing on the Origin worked out really well. We're able to print 18 parts every 2 hours. And so again, that process is really fast. And it's all about the more parts we can stick on that tray, the better the per part price is, because it's 2 hours if it's one, it's 2 hours if it's 18. So the only additional costs are really the processing and the material considerations. For the material, we use the Loctite 3172, which this particular batch came in this really cool cyan color, which made it pop and made it feel very like a consumer product, which was neat. And it also had another benefit was it has an elongation of 111%, which is fairly unique. I think it's almost completely unique, but pretty rare in the 3D printing world that to have something with that much elongation. It's really behaving a lot like a PolyPro at that point, and not necessarily PolyPro-like. And so, the takeaway with this project is, the economics, that price curve, that bell curve, looks really good for a product like this, for these, really small batch applications, and with the Origin process. Okay, that's the last application. So looking forward, the future is still bespoke, and it's an exciting time. I mean, it's not going to be one-off Italian suits, but I do see these kind of niche markets appearing and being addressed, and companies basically taking advantage using a new tool set, like with additive manufacturing. So we're seeing a lot of just-in-time manufacturing, like with the ventilators. We're seeing better materials out of Loctite, these kind of engineered materials that act more like traditional commodity plastics. The Origin P3 allows for faster print time, which ultimately basically reduces the risk by dropping the cost from a per part. And it's really been fulfilling for me that, 2021, the kind of leap that I took and InterPRO took to offer these production parts off these printers did work out. The best vote of confidence was the clients would just send a PO to reorder more. And so that means we're on the right track, and it's not a pipe dream, which is very, very exciting. It's nice because I believe that we're actually fulfilling a need, and it's no longer just a dream. So, production 3D printing is here and offers a competitive advantage to our clients over traditional methods. So anyway, my name is Dan Straka from InterPRO, and thanks for watching this.
Thank you, Dan. Yes, you are on the right track. What I really liked about your presentation was the looking at the manufacturing process evolution and the intersection of the hardware and materials, and then bringing it into the application. So I thank you for that. This is excellent. Next up, we have David Leeson from Glidewell Labs.
Hello, everyone. My name is David Leeson. I'm VP of Engineering at Glidewell. I'm here today to talk to you about cloud-connected additive manufacturing in the dental industry on behalf of Form Labs. Glidewell is the largest dental lab in the world, both by sales and volume. We have 4,700 employees in 5 countries. We serve more than 80,000 dentists, which represents about 60% of the US market. We also produce 100,000 units per week, and every one of those is a patient-specific product, which represents an enormous array of natural variation. And we have been using additive manufacturing as a way of delivering on those patient-specific demands for many years. To give you another piece of context there, we consume 15 metric tons of resin per year, or in anyone's terms, an awful lot of teeth. So I'd like to take you back to March of 2020 at this point. Surprisingly, January and February of that year had seen an unexpected uptick in sales, we believe due to a lot of our competitors using offshore manufacturing that have been more disrupted than our own. But in March of 16th of that year, the ADA began to recommend that dentists postpone elective procedures, and we saw a dramatic drop in sales. So we began to be pretty concerned about business consequences of this, apart from all the other things we had to be concerned about. And we were questioning, how do we keep serving our customers and their patients during this time? How do we keep our workforce safe and productive? And will dentists have sufficient access to PPE to perform essential procedures? We naturally expected them to be quite down the list in terms of priorities, and we weren't really sure what kind of impact that would have. So at this point, I need to provide a little bit of kind of technological context to the situation. If we look back to 1970, you can see a picture of Jim Glidewell himself, our founder and CEO, working in his apartment there. And this technology we used to produce dental products at that time really hadn't changed for 100 years. It was very manual, kind of artisan-based craft, and it took a lot of work to do so. If we fast forward to the 2000s with the CAD/CAM revolution in dentistry, we start to see the use of additive manufacturing and CNC machining and CAD/CAM technologies. And fast forwarding to 2014 is when we began to use cloud-connected infrastructure, and we began to implement what I call islands of automation, which were mostly machine tending applications. And in 2019, we made big strides towards building these full digital large-scale factories. and applying lots of machine learning to those. Notably, in application of generative design, I believe we're the first company to apply a technique called GANs to generatively create 3D data that we use to manufacture our dental products. Now, I'm going to pick up a little bit more on that cloud connected piece. This slide is an old slide created by our CTO, Mike Silveris, back in 2012. It kind of charted the vision that we had for cloud connected manufacturing that was finally implemented in 2014. And you can see here the animations showing lots of locally hosted components, the software that will move to the cloud, and the various different modes of operation across our distributed manufacturing network that has a lot of local sites spread across the US and internationally too. And just shows the resilience of those systems being able to acquire a scan in any location, design it in any other location, and then manufacture it at still another location. And one of the visions of this was in terms of having a very tolerant disaster recovery system in place, but we never envisaged anything like a pandemic. Our thinking was mostly driven by being a California-based company, the threat of earthquakes, and having to move a lot of our manufacturing away from our large facilities here in California to put more load on our distributed network. But as fortune would have it, those same qualities that would protect us in those circumstances lends itself rather well to the pandemic. If we think about it, having a cloud-based design system and routing engine to move digital data through our system and redirect that manufacturing flow, that lends itself very well to moving design workers that to be able to work from home if we need to. And it just provides dramatic flexibility in terms of whatever local forces are at play. If we need to quarantine a certain facility, that work can easily be moved somewhere else without having to physically move any product or even employees. So this is really one of those key building blocks that set us up for success in this environment. And another dimension of helping our customers better serve their patients safely, we developed some approaches to telehealth along similar lines to that of large direct-to-consumer orthodontic companies such as Smile Direct Club. We provided a self-impression kit that the dentist could then in turn provide to their patient, and along with some guidance and instruction from the clinician, successfully capture the dentition geometry that we could then digitize. So rapidly handling all of those physical impressions poses a little bit of a challenge for our nice distributed cloud-enabled manufacturing infrastructure, as we have to rely on 100-year-old manufacturing techniques around the plaster model here that you can see. And it's a very laborious process and requires a significant footprint of facility and a lot of labor to do so. It's only after we have that plaster model poured that we can then digitize it, as you can see on the lower right. An alternative approach that was developed to address this is using CT scanning to digitize the impression directly. Impressions have lots of line of sight issues, a very complicated geometry that any kind of triangulation approach to optical scanning is rather problematic for. CT can handle impressions very rapidly and very accurately, and that really enables us to digitize as far upstream as possible, which is always a core principle for us. So to summarize a few of those points, the automation that we've invested in naturally allows lower density, safe post-COVID working conditions versus a conventional lab. The distributed architecture that we have in our manufacturing system allows that flexibility to deal with any kind of local conditions and issues. And by digitizing as far upstream as possible, we get to maximize those benefits. I'd also add that direct-to-consumer healthcare and telehealthcare is a big trend in our industry, and additive manufacturing, I think, is a natural partner to it, along with these other digital technologies. So let's get back to talking about that PPE shortage we referenced earlier on. So in March of last year, there were a lot of 3D printed respirator designs circulating out there, none of which were very comfortable, scalable, sealed, and certainly didn't have any analysis or testing behind them. So we needed something of a higher grade to provide to our customers. So early one Saturday morning, this text image of a concept arrived in my phone, and the concept was simple, a reusable, replaceable filter design, and it would leverage our form cells to do high volume printing of the filter housing, and we would use our in-house injection molding to make a TPU body that's nice and flexible and comfortable and is a medical grade material. Now, we also used the form cells to really be aggressive about our design iteration process. And I just want to show you a quick picture here of the gentleman who actually sent me that text that day, James Samora, who's the lead on the project. And we went beyond that kind of normal ideation, prototype, testing and feedback loop. And using the capacity of the system, we really pushed out and did multiple designs and tested them in parallel. I think that was key to how quickly we were able to complete the project. So we were very happy with the outcome of this project. We got many thousands of these out to our dentist customers right when they needed them most. We went from concept to mass production in just a few weeks with minimal tooling costs thanks to the form cells, and followed the FDA EU guidelines along the way, and achieved a 98% filtration efficiency at a 220 Pascal pressure drop. And the take-home message for me out of this project was, don't believe your own hype. You've got to be realistic about the limitations of additive manufacturing techniques that you have available to you. And even when you're under this kind of extreme time pressure, a hybrid approach using conventional tooling can often win the day. So there's a couple of recurring themes here. Digital workflows are naturally agile. We may not know what the future has in store for us, but that agility can give us the best chance of responding to the environment. We have to keep innovating. The technological investments that we made during the good times help carry us through the bad, and I feel that's a significant component of the successful recovery that we made. Thank you very much for listening to me today, and I look forward to your questions. Bye.
Thank you very much, David. This presentation is absolutely perfect with our ARC Forum theme of digital transformation, COVID, and the evolution of technology. Well done. I'd now like to invite everybody to turn on their cameras, and we will begin our panel discussion. And we have 3 suppliers with us, and I would like to have them each introduce themselves. So I'd like to start with Aaron Frankel, please. Please give us an introduction of yourself, your company, your title, and a little bit about what's happening.
All right. Thank you so much, Marianne, for having us, and thank you everybody for attending today, and especially Faisal for joining us and presenting as on behalf of Siemens and our strategic partnership. So my name is Aaron Frankel. I work for Siemens Digital Industry Software. Siemens Digital Industry Software is a company that helps manufacturers become digital enterprises by digitalizing and integrating their entire value chain from PLM software through manufacturing operations management and onto the shop floor with automation. My role at Siemens is to lead our additive manufacturing software program. And so I have responsibility for defining our end-to-end solution for additive, going all the way from order to design for additive manufacturing through generative engineering, product design validation, build preparation, simulation of the process, post-processing onto the shop floor for execution and into quality, as well as how we connect a platform of suppliers and manufacturers to be able to connect demand with supply. we have a breadth of technology and a wide variety of customers in numerous industries adopting additive manufacturing. And as a part of my role, I really enjoy working with companies like Baker Hughes and others who are pushing the boundaries in their adoption and industrialization of additive manufacturing, making additive a core part of their businesses and helping them address the big challenges which we take to heart and how we try to solve them to deliver greater value. So thank you for having Siemens and myself and Faisal, and looking forward to participating in the panel.
Thank you, Aaron. And of course, Faisal, thank you so much as well. I'd like to also remind the audience to please start putting in some Q&A questions for us while we introduce Patrick Carey from Stratasys.
Thank you, and welcome everybody to the conference. I'm Pat Carey from Stratasys. Been here in my 8th year here, and as you probably know, we're one of the original pioneers in the 3D printing world. We've been in this business for over 30 years. My role is I'm the Senior Vice President of Products and Solutions, and I'm not a product development guy, I'm more of a field guy in terms of how do we bring our products to market, focused on our customers' demands. So great to be here and have Dan represent us with our new P3 printer from our Origin acquisition, and to see great partners like my friend Aaron at Siemens. He and I tend to speak a lot together, and to see Baker Hughes, one of our biggest customers. So that's enough about me. We can keep moving.
That's great. Thank you, Pat. And of course, Dan, thank you. Now, Dan Recht from Formlabs, please introduce yourself.
Thanks, Marianne. Thanks, everyone, for joining us. I'm Dan Recht from Formlabs. I lead business development for us globally. And at Formlabs, business development is the part of the company that is working with customers to push the boundaries of what's possible with additive manufacturing. And so Glidewell is for sure one of our flagship stories. We also work with companies like New Balance and Gillette. In all cases, trying to get large established brands and industry leaders to reimagine how they can use additive. And I'm excited to be part of this panel to help both the audience understand their capabilities and also learn more from the other panelists.
Thank you, Dan. I'm excited that you're here as well. So let's kick off with some questions. I'd like to start with each of the suppliers first on this question. We've been on a journey with 3D printing now for quite some time. What obstacles have we overcome, and what challenges do we still have ahead to march forward and make this a widely adopted, end-to-end industrialized additive manufacturing solution? So, we know where we've been, what have we accomplished, and what do we need to do to really propel this forward so that next time we're together, we're even further on the journey. So Aaron, I'll start with you, please.
Okay. As far as the challenges that we've overcome, I believe that we've proven that additive design and manufacturing can create significant value for the companies that are using it in situations that complement or augment conventional design and manufacturing processes. I think that we've proven that it can help us innovate better performing, personalized products. It gives us manufacturing flexibility, and the combination of product innovation and manufacturing flexibility is allowing companies to explore and transform business models. And I think that as a part of that, we've developed the tools, the digital infrastructure, the software that's enabling organizations to make those transformations in product development, from being able to scan parts or anatomy and end up with a product, to design or automate the design of parts that have been lightweighted or minimize the amount of material or improve performance through flow or thermal management optimization, and give us the capabilities to innovate much quicker than we could in the past. I also think in the production side and being able to plan for manufacturing, we have tools that allow us to be able to prepare our designs for production. and eliminate conventional manufacturing processes, molding, castings, tooling, combine parts together into single parts that might have had to have been assembled, and even be able to connect to a supply chain digitally. So the tools are there. And I think that in many cases, you're starting to see the emergence of automation across that entire digital value chain, and how we move data through the different applications and into the physical world to be able to control production. But I think there's still a number of challenges ahead of us, and we encounter these challenges all the time when we speak with and we work with our customers and new customers in their journey in adopting additive. And I think one of the first challenges is related to scale, and how do we scale up additive manufacturing? How do we understand within these vast bills of materials of these products that we're producing today where additive is able to provide value, and where should we look to unlock the value of additive? And I think we also, as a part of that, face this challenge in education, changing the mindsets of organizations, both leadership and at the technical level, to understand the value of additive and how to apply it. And once we overcome some of these challenges for companies who have been in the additive space for the last decade, I think we continue to bump into issues related to process consistency and quality assurance, and the continuation of how do we automate these processes. There's so many different additive technologies and materials out there. We have yet to capture knowledge digitally about all of those different technologies that are emerging so fast, and the materials to be able to equip the people who want to take advantage of that. And I think that we have the infrastructure in place to capture that know-how, but there's still work to do to be able to document the breadth of that so that we can all capitalize on it. And I'll stop there, but there's a great opportunity to lie ahead.
We could actually, we could continue to talk and debate that, but Patrick, I would like it if you can comment on that or add to it, please.
Sure, I'll take a little more technical perspective of it. I've had the advantage of spending hundreds and hundreds of hours with Scott Crump, one of the pioneers of our industry. And one of the things that we've done well and things we can build on is when he came into this industry, he came from the CAD CAM industry, specifically around CAM and G code. Well, G code is the code that drives, for example, a CNC machine. When he built the first machine, he built the first FDM machine based on the software he already had from a CAD CAM perspective. And that's what enables CAD to print today. And a lot of people don't understand that's what's really enabled our industry, is that he did that. Being able to print a part is interesting, but being able to print something repeatable and reliable at that level enables us today, 35 years later. Where that would take us next is the CAD to print workflow is pretty good today, primarily STL focused. As we look at the next level of how do we take all of that great stuff that is going into CAD today, and how do we print all those features beyond the basic. So that's how we got here, as well as where we're going. The other thing that we've done as an industry is we focused on printing known materials. So to get into a factory, we had to go there and say, yes, we can print ABS. Yes, we can print stainless steel. Yes, we can print polycarbonate. But all we're doing is printing things that are known from another process. I believe the future, the big future, is being able to print things that are not other materials, being able to print materials that are new, designed for 3D printing, designed for additive. I think that's the future. And exciting for me personally is when we see the large chemical manufacturers get into this industry. And for example, Dan's example about Loctite, to see the innovation they're able to bring quickly as they're able to make materials just for this process. To me, that's the most exciting future. You talked a little bit about standards in your early presentation, Marianne. I think standards are important. I come from large companies and 2 industries that standards is what drove adoption of a technology. So I think we need more standards here. We have a file format standards, all we share as an industry. We're just becoming mature enough, I think, that we can start to build standards bodies around how do we do this. And as we get into manufacturing and production, we're going to need standards because those are all those factories are built on standards. Connectivity is another area. So these machines from prototyping have been data, they've generated data inside the machine. They now need to connect to the factory floor. And as we know, the factory floor is a software-driven entity. It needs data and it's going to give data. It stores data around parts. When you're making certified parts for an airplane, that data needs to go somewhere. So connectivity and standards are somewhat interrelated, but I think those are some of the areas that we're going to focus on and where we're going to go as an industry.
Excellent, Pat. I will circle back about standards and workflows. I'd like to give Dan an opportunity to weigh in also on how far we've come and what challenges that we really need to overcome to really bring this forward.
Yeah, absolutely. In thinking about how far we've come, I like to measure from the 2012 hype peak, where the world believed that additive manufacturing could do literally anything. And there was a crash after that. And I think we went from great optimism to key thought leaders being really skeptical of additive. And we've crawled out of that to a place where I would describe us as 80% there. And what I mean by that is we're printing credible materials at low to medium volumes at decent costs. And unfortunately, it's probably only half the work that it took us to get to 80%. And now we're going to spend the other half of our work as an industry going the rest of the way to 100%, where we're really in mature manufacturing technology. And I think really in terms of the nuts and bolts of that. So like material properties, the entrance of more companies has been great. At Formlabs, I'm really proud to say we actually manufacture our own materials from the ground up. We design them, we formulate them, we produce them. And as a result of that, we really have the control necessary to push these material properties that last little bit to industrializability, to work with our customers to drive the ROI up. The other thing where I think like big progress still needs to come is in automation, both software and hardware. I love the idea of standards around connectivity, where we want our machines to be integratable into the factory floor. One of the things that I really like about our work at Formlabs is we work from a position of modularity, that we try to deliver the capabilities of $100,000 machines in $5,000 to $10,000 packages. And that creates this opportunity to have these swappable, scalable units. But those units need to talk in a predictable way to existing manufacturing systems. And that's a place where I think everybody in additive and also the makers of manufacturing execution, PLM software, need to get together and say, okay, this is how you listen to a 3D printer and this is how it talks to you.
Once again, I'm going to come back to that whole automation and software discussion as well. But before I do that, I'd like to give the speakers from the perspective of the end users. I'd like to turn this on its head and ask the three of you, what is it that you need to see coming out of the suppliers going forward to enable what you're doing? So if we can kind of go in the order that we had you speak in, Faisal, can you please talk about, what do you need to see more from your suppliers?
Yeah, thank you for the opportunity for this part of the panel. Yeah, it's an interesting discussion. So just to kind of start from the question of what we have done over the past 10 years as an industry. So we've come from the part where we used to do prototypes to really making production parts, right? And then now from those production parts that are non-critical is still there. We need to move to all the critical parts there. And I'm talking from the perspective of oil and gas and energy industry there. It's highly regulated. So you were talking about the standard perspective. We still have standards that dictates the parts and parts material properties that are based on the testings that were done on traditional manufacturing. So to convince our industrial bodies that the 3D printing, the material properties coming out of the 3D printing is as good as or equally better, it's still a challenge for us, and still we're working towards it. And that will basically help us to move from a non-critical part to a critical part type of where a bigger inventory of parts come into our play there. Now, coming in terms of the gap side of it, if you look at machine cost, they are getting better improved. and their productivity is getting improved. Also, we used to have single laser, we have now multiple lasers there out there. So that's the other path going on there as well. In the digital tool side, if you had asked me this question 3 years ago when we were started looking through a lot of these digital tools, I would say there was a big lag around it. Yes, there were some generative design tools were out there, but they were still not working cohesively together. As in general, vendors have basically made a strides around it. There's still a lot way to go to build a full digital thread there. I'll give you example for this generative design there. Now, for us in oil and gas, we're high temperature, high pressure environment there. For us, flow channels are very important. For us, temperature management is thermal management is extremely important there. But if you look at the current generative design tools there, they're targeted toward aerospace or automotive, the balance, optimizing your stiffness or mass there. Those things are important for us there, but we have other requirements that drives these parts completely different shapes and features. So that aspect's there. Then also, if you look at it, the part quality issue. So we still spending quite a bit of time in qualification, part qualification. I mean, and you can take it the whole from life cycle. It's a multiple months of this, just getting the part to the printer in there and then kind of running through the iterative cycle. Once you get to the printer, it could be days or the weeks in there, but that cycle has to be, taken down also. And we're working pretty aggressively around it. So the part quality still remains, it's a big thing for us. And I'm talking from the perspective, especially from the metal side of things. If we have, and to Patrick's comment, the polymer side, we are to very close to print. From the CAD to print is a very seamless workflow in there. But from metal side, we still have a lot way to go through it to get to the push to print state in there. So there's quite a few challenges that's gonna lie ahead of us. And then we're working very closely with companies like Aaron and others as well to kind of build up this ecosystem that we can move forward.
Excellent, very consistent responses. What about Dan? Do you have a comment too for what would bridge the gap between the suppliers and the end users?
Yeah, I'd like to touch on a few things Pat said and really echo, like the ability to create unique materials is pretty fascinating. And I know when I started in 2005, we had white and clear. So in some ways, the job was very easy. Do you want a clear part or do you want an opaque part? So now that there's so much options out there, even between different machines, I think there's not one 3D printer that is a silver bullet for anything. We have MJF and SLA for good reasons, because there's different applications. So I think the thing that becomes really important is communication and just asking questions like, what are your clients asking for? As InterPRO, I remember when I was making parts, I took a lot of pride in physically, getting a part done and putting it in a box. And now my pride has shifted because, I'm not making parts for myself, I'm making parts for other people. And, when I was younger, maybe I internalized too much and tried to guess and tried to figure out and think about the best option, where I could have just, picked up the phone and asked, like, do you really need that ABS-like material, or this is faster and cheaper? And so what's been kind of exciting now, and what I would encourage is, discussions like this, where we can talk openly about what our clients need, and it kind of funnels up the chain real quick and comes back down. And so the design and material iteration cycle is really exciting, where materials used to come out every couple of years. With some of our partners now, it's almost like there's a material every couple of months, which is a different problem, but it's a great problem to have, because like I said, every material that we can run effectively is another problem that we can solve for someone that we couldn't do that a year ago.
Excellent. Let's stay on the materials side for a moment. A little bit of a controversial subject on materials. I want to talk about the proprietary materials model versus more of an open model for materials. And I'll just kind of throw that out there for someone to please jump in, because I've heard I've had this conversation with either directly with some folks here or maybe within your corporations. Let's talk about that subject. So having a proprietary materials model where you have to purchase just from one, wouldn't it open it up? Wouldn't it open it up if we could have more of an open materials model?
So
I'll take that. Or somebody want to go? I'll take that being the big, the Death Star of proprietary materials, maybe to some people, because we built our company on that, right? And the reason we did it is because we needed to make materials that printed properly, and other materials didn't. So there's a long legacy of doing that here and being able to focus on reliability and repeatability of the print. And that had to happen. And I mean, I ran sales here for a number of years, and I was always yelling, we need materials faster. And we print a new material between 30 and 50,000 hours before we release it. So it's a phenomenal, you can't just take a material off the shelf and print the level of parts that we want to print. However, we know this proprietary materials business is of the past. As we get into production, we get into higher volume. So you see things like our Origin acquisition that brings with it an open material strategy. We announced our V650 SLA machine last year that has an open material strategy. We partner with DSM. So there's a hybrid strategy, I think, as we go from prototyping to production. And you're seeing us get through that as a company. I can tell from the past, I was a longtime IBMer. I was there 18 years. I was in the Unix area. And the very famous going from a proprietary operating system to creating Linux, helping actually we took our IP and created an open source product that competed with ourselves. And I can tell you, I was in the meeting shouting against it as a young guy in my 30s, like this is going to kill the company. And it ended up to be what saved the company. So there's something here. I think as an industry, we need to work through it. But I just wanted to put that out there. There's a hybrid strategy that will help the customers produce what they need to produce and will make us all successful.
Anybody have a comment on that on the panel?
I have a quick comment on that. So, I mean, I feel like until recently, you know, the big AM companies were really waiting for the chemical companies to help them with materials. And, you know, if you're talking to BASF or, you know, another similar sized chemical company, AM just wasn't a big enough industry to be really important to them. So I don't think it had the attention it needed. And, you know, in the last few, I mean, so my typical comments to a company coming to sell me a piece of equipment would be around materials, because it's the material properties that enable new applications and then drive return on investment for us. And that's been changing rapidly in the last few years, as in line with the comments of a few of the other presenters here. And particularly for me, it's about having more impact resistant materials. And you know what I'm seeing as a general trend, and as Dan mentioned, is that the AM companies themselves are taking responsibility for materials development. They know what's needed. They're intimately familiar with the process, and they can make us materials that really you know, deliver the application needs that are required. And you know, I think that in turn is starting to, you know, go full circle and making those big chemical companies take more notice and really apply more innovation there. So I think that's a good trend.
Yeah, I would maybe add to that I think there's a really good case for both. You know, being a service provider, and from a risk standpoint, not every company may have the culture or the rigor to onboard open materials, and they may just want a catered to experience. I mean, our FDM by Stratasys is bulletproof. We never have, unless we don't clean a tip in time, it always resolves, and there's a comfort in that. And whereas other materials are maybe a little bit riskier, and you know, it's a leading edge, bleeding edge sort of thing, especially as a service bureau, we're always trying to fail very quickly. But I think there's a really good example for both, depending on, you know, the end user's needs and capabilities and comfort.
Great. David, I cut off and went to the materials discussion before giving you an opportunity to talk about additional, you know, what you'd like to see from suppliers. Is there anything to add to that?
I'll make it very quick. So it used to be that the limitation was always around return on investment based on the initial capex, and I think that's something that really Formlabs has changed for us, right? They by making a quality product at that low price point, they kind of brought the whole industry pricing down. And then that conversation now is back to I say more around materials availability. But I see that changing rapidly. So I think the next hurdle and the next holdup in terms of return on investment will actually be around post-processing. That's the piece of it that kills the ROI for us. Yeah, so that's another thing there. And the connectivity piece that people have talked about, I think that's a really simple thing to solve, and lots of the companies provide nice modern RESTful web service based APIs, and that's something that works for us for the form cells, and we can really get all the data that we need out of those systems, and it's a minor challenge compared to the other technical hurdles we have. So I'd be very surprised if that isn't completely solved in a very short period of time.
Sure. Excellent. Let's talk about software for a moment. Let's talk about, I have a question here, generative design software for additive manufacturing. Is this primarily coming from the PLM providers, or are there point solution providers coming on board for that? You might have an opinion on this. And Aaron, of course, I think that you might have an opinion on this as well.
I was letting see if Aaron went first or me. I'll go first.
Yeah. I was waiting for one of you to jump in.
Yeah. Since I came here from Siemens, so it's kind of I got to be careful what I say. No kidding. I think it will come from both. I think that the integration of innovation into these legacy systems, and that's not said as a pejorative, these large complex systems that run factories, the PLM companies have to provide this. However, you look at what a small nimble company can do that is only creating a point solution, they can innovate faster and aren't dragging with them legacy code as technical debt. So I think it's going to be both. And I think we'll see innovation in the small companies, then acquisition by the large companies. That tends to be how innovation works. So I think it's both. I mean, you saw us recently, we partnered with Entopology. I mean, they're able to do stuff with our machines that we can't even imagine. And of course, we have our own software division. We wish we would have done it ourselves. But the nimbleness of what they're able to do and the IP they have is amazing. So you see us partnering with people like that.
Aaron, anything to add to that?
Yeah, I would say that certainly there are PLM companies who are providing generative engineering technologies, as well as small niche vendors who are focused in particular areas of optimization. I would say, though, that there is a caution in looking at niche vendors focused specifically on trying to create geometry for the purpose of trying to improve performance of a design, in that you need to be able to understand how that part is going to perform in the environment that it's going to be used based on the process that was used to make it. And so we need to start looking beyond just generating a design, but also generating the design for a particular material and manufacturing process, and then being able to validate that design is going to perform in the broader system around it. And I think you're going to have the ability to take whatever design you generate from whatever system and still put it into the broader design context to make it work. And so if you're going to look at a niche vendor approach, I would say keep in mind the fact that you're going to need to be able to validate that design and be able to prepare it for printing and understand the costs associated to using different systems in order to do that. And one of the things that we're doing at Siemens is investing in a number of the different areas related to generative engineering, focused not just on structural optimization, but also looking at flow and thermal and how these tools need to be able to interact and understand the materials and how those materials are going to be used in the environment that they're going to reside, and build a broader solution set to be able to quickly validate before we start producing at scale. And I think that we've got a number of exciting projects that we're working on with a number of companies to work through these broader workflows in order to be able to take advantage of these additive parts in end use products. We've done a lot of work within Siemens and within our customer base. From Siemens is a broader company related to Siemens Energy, for example, and doing gas turbine engines. There's been a lot of engineering that have gone into components in some of these systems around using generative tools to optimize the performance of the overall product itself. And we've seen some magnificent results out of it. It's an area that we're also exploring a little bit with Baker Hughes, and maybe Faisal can comment on some of the things that we've looked at together.
Yeah, I mean, thanks, Aaron. So I would agree with Pat and then Aaron in context, because the PLM companies have a well-established user base with established tools. And it's not like the additive coming in and basically replacing everything that they've been done in there. So we will continue to design our current products with the current tools in there. Yes, additive is adding to the mix in there and helping us to reshape how we would redesign our products in there. So the challenge for companies like Aaron, Siemens or big ones is because they have a bigger portfolio, how do they continue to manage investment? And then the eyes and the ears of the CTOs and the CEOs that this is a place that we need to continue to grow and then provide to our customer in there, because there are other pieces also you guys are working on it. And then bringing the speed to it, because that's the advantage for this niche vendors are coming in there. They're picking up individual solutions, point solutions in there where we have interest to it, and they can just focus all the energies towards that and then provide you that solution. Like you mentioned about Pat getting the connectivity to your machines in there. So, I mean, as a customer, we've been working with Aaron around these generative design tools in there and continue to push towards various areas that where we need, just like I mentioned in my past comment, that we need tools which are more multi-physics driven in there. And thanks to Aaron and his team and in Siemens, they're working in an agile mode. So this was not kind of mode in other areas when we worked in the past there, but it is truly understanding that they have a competition on the other side, which are niche providers in there. And then to compete in that area is to really work in an agile mode and then be innovative, right? So don't lose the innovation part of it. From my perspective, it's important that both, all of these options are available, and that will continue to drive the innovation, because right now additive needs a lot of innovative ideas and innovative solutions in there, because as we scale up in there, through natural progression, yes, there may be some mergers and acquisitions could happen in that case in there. The niche providers also have to make a case of how do they fit into this bigger ecosystem. You already have well-established tools of CAD, let's say NX. We use extensively NX for across Baker Hughes in there. How do you, if we were to do design part generatively outside in there, how do you bring it back into it, and how do you take it back? How do you do this loop in there? So yeah, it's one thing to create some niche solution there. How do you fit into it? That's to Aaron's point, and to have a part of a bigger digital ecosystem. So one of the reasons we are working with Aaron's and the team and Siemens is kind of build up this design studio environment and have a digital design thread. From the time we do the generative design, we have a CAD model available to it. We can do a prep into the same system. We can do the build process simulation into the same system, and then we can have it all managed within a PLM type environment. And that gives us this advantage of quickly go through the design cycle. And the speed is extremely important, especially if you're trying to replace a part in the field, which requires a 3 to 4 days or a week time because it just went down. And we quickly scanned it and then run through the design studio environment and be able to print it within a week. So those are some of the aspects that I would say.
Excellent. Good. Any other comments on this topic here?
I have a quick comment.
Yeah,
I was going to say that, when you're looking at the requirements of this software, right, it is as broad as the application of additive manufacturing itself, which is just massive. So I think as a result of that, there's kind of a space that those PLM providers can address, but it will never match the full breadth of additive manufacturing, right? That space will keep growing as things become more established, but there's always room on the fringes for niche applications. And we look at what my company does, we have to generate tens of thousands of unique CAD designs every day, right? And that's just not possible with any conventional tools. And what we actually had to develop for ourselves, because there isn't anything in the market that can do that, is actually all AI driven now, and the designer, so to speak, actually becomes a quality control person and is not directly involved in the design process, right? So you can't make a universal product that's going to have that level of automation, right? That's very application specific.
Yeah, it builds up to this larger idea that like a generative design is only as good as the physics that went into it. And that physics can be really field specific. So the considerations that go into creating a good CAD file for a dental arch from a scan are very, very different than what might go into an engine part or a flow channel. And what's interesting is as generative design, both independent tools and built-in tools are becoming more popular, simulation hasn't kept up. And there's consequences to it. I think one of them is if I were a simulation provider, I'd be a little scared that I would get disrupted by someone who's targeting specifically generative and specifically additive manufacturing. That it's kind of the blind side of this, but it's a huge opportunity.
I would agree. It is a huge opportunity. It's something that you have to be aware of. But as a PLM vendor, I think that Siemens is unique in the sense that we have a open culture where we understand that we're not going to be able to develop everything ourselves, and that we have an openness built into our system, to be able to connect a broader ecosystem of partners in order to plug in solutions. And that's something that we value and we look at and take very seriously, not just in additive, but also across the wider portfolio set. But the industry moves quick. We're not going to be able to do everything ourselves. And it's important to be able to keep an eye on the industry and work with industry in order to push the limits together.
One of the conclusions that I draw from this panel is just how diverse, just each of you here today, but how diverse the needs and the solutions that additive manufacturing can solve. It's different for David and Dan than it is for Faisal. There's so many opportunities and use cases and applications out there. We are coming to the top of our hour here. So I want to give everybody a big round of applause here. I want to thank you for your expertise, for the insights that you have brought. I'd like to thank our audience, and I would like to remind our audience to please rate the session. And I'd like for everyone to just enjoy the rest of the forum that we have going on today. And I really do appreciate your time and your efforts and your insights. Thank you, everybody.
Thank you, Marianne.
Thank you.
Thanks, everybody.
Thank you.
Thanks, Faisal. Good seeing you
Thank
back.
you, Aaron. Thank you, everybody.
Yeah, Aaron.